Okay, picking up where we left off with the January 2019 Algebra 2 Regents exam. We are starting on the part 2s in this video, which is question 25. Just a reminder for part 2s, 3s, and 4s is to make sure you show all of your work to ensure that you get full credit. Okay, so number 25 says justify why blah is equivalent to blah using properties of rational exponents. So I love questions like these that say stuff like is equivalent to. It's telling you they're equal to each other. You just have to work through some algebra and some exponent rules and stuff like that to simplify this down and prove that they actually are equivalent to each other. Before we jump into actually doing that, little side note down here, it says where x is not equal to 0 and y is not equal to 0. Those are your excluded values for this function. All it's telling you is that if x was 0 and if y was 0, your whole denominator would be 0, and that is an excluded value because you can't have a 0 in the denominator of a fraction. So it's not super important information for the problem. It's just important information to keep in mind all the time, and it isn't technically mathematically correct without stating that. So that's the only reason it's written there. I just wanted to bring it up to you so that it doesn't trip you up on the exam if it says something like that for a question like this. So now I'm going to get into simplifying it. First thing that I noticed is this one's definitely busier. It's got a lot more going on than this one. So this is the one that I am going to be simplifying. The other thing that I noticed is that it has radicals and, roots, whatever you want to call it, and this one does not. So the first thing I'm going to do is convert this from radical form to a fractional exponent, and that is through TIBO. So for the very first one on top, it's x squared, and it's a cubed root. Using my top inside, bottom outside to turn this into a fractional exponent, that means that inside 2 is going to go on top, the outside 3 is going to go on the bottom. And now with the y is being raised to the 5th on the inside, so it's going to be 5 over the 3, which is on the outside. Now, same idea on the bottom, except it's a 4th root now. So when I have my x, it's raised to something over something. The inside number goes on top, so 3 goes on top. The outside number goes on the bottom, so it's 3/4. And then y is going to be to the 4 over 4. Okay, clearly that's not equivalent to this yet, so I still have some simplifying to do, so off to my next step. All I can really do with this, because I have similar letters on top and bottom, is do division. When you are dividing, you have to subtract your exponents. Now this entire problem is telling me to justify why they're equal, so I want to show all of my work. I'm going to show that I do 2/3 minus 3 over 4. Okay, so in my calculator I would plug in 2/3 minus 3/4. Get a decimal, so I math enter it, and I get negative 1/12. That's a good sign because I go back up here and I look, and that is negative 1/12. Perfect. So now for the y's, I do the same thing. 5/3 minus 4 over 4 is just 1. That's 3 over 3, so that'll get me 2/3. Also a good sign. So now when I rewrite this, it's x to the negative 1 over 12, y to the 2 over 3, and you're done. You just have to now state that that is equal to that original expression that was up here, x to the negative 1 over 12, y to the 2 over 3. Okay, I've showed all of my work. I proved that they were equal. Remember, the word justify means show your math to back up your answer. We showed all math and all work to justify that that's equal to that. So my answer is that. I'm done. All right, on to 26. It's a graphing question. It says the zeros of a quartic polynomial function are 2, -2, 4, -4. Use the zeros to construct a possible sketch of the function on the set of axes below. So I have to remember what a quartic function is. Quartic means x to the 4th, and what a quartic function looks like, just as a quick sketch, is a W-shaped graph, or if it's a negative quartic, it would be kind of like an M-shaped graph. But the overall idea is that if my axis is here, it has 4 roots. And then same idea for this. My axis would be here, 4 roots. It doesn't have to be there. My axis could have been here. The reason I'm drawing them there is because when I read ahead, I see that it has 4 roots. 2, -2, 4, and -4. So if those are my roots and I have to have them labeled, I'm going to first scale my axes. This is 1, 2, 3, 4. Same thing to the left. -4, -3, -2, -1. Okay, so I have to plot the zeros. Zeros, roots, x-intercepts, they're all the same thing. They are points on the x-axis. So I have one at -2, I have one at -4, +2, and +4. When I connect them using the quartic shape, nowhere in the directions does it tell me it has to be positive or negative. So do whatever your heart desires. Whether you wanted a W or an M, up to you. I'm going to do a W and just make it a positive because, you know, when studying for the Regents, we have to stay positive. That was really corny and I apologize. But there's my quartic function. It goes through all of the zeros that it said it was supposed to, and I'm good to go. So on to number 27. Kind of a weird question, but it says, Aaron and Krista were working on cubing binomials for math homework. Aaron believed they could save time with a shortcut. She wrote down the rule below for Krista to follow. Does Aaron's shortcut always work? Justify your results algebraically. So if I need to see if this always works, I would have to simplify one of the sides once again to see if it would be equal to this always. So this side is the more complicated side. I'm going to simplify that by cubing it. Okay, when you have something cubed, it means you're multiplying it by itself 3 times. So this is, this is going to be a plus b times a plus b times a plus b. Now, it does not matter which 2 you start with. I recommended in class a long time ago in the beginning of the year that those need to be multiplied together first, because then it just makes a lot more sense to multiply this through to the trinomial that you'll end up with. So to each their own, but I'm going to start with those second 2. So I'm going to bring this a plus b down and multiply this out. So first, a times a is a squared. A times b is a plus ab. This in here is ba. I'm just going to write ab so they're easily recognizable as like terms. And then b times b is b squared. Okay. Now at this point I could multiply this out to all 4 of them, but what I'm going to do instead to make this a little bit easier on me is combine my like terms. So this a plus b, it's going to come down. I have a squared plus 2ab plus b squared. And I'm going to multiply this out. So the a goes to the a squared, that's going to be an a cubed. A to the 2ab is a plus 2a squared b. And then a times b squared is a plus ab squared. Now I multiply the b through. B times a squared is a plus a squared b. B times 2ab is plus 2ab squared. And then b times b squared is going to be a b cubed. Okay, so I clearly have to simplify this. Be very careful when simplifying because you have a squareds, b squareds, a whole mess in here. But when I do simplify, I'm also going to put it in standard form. So I'm going to bring down the a to the 3rd first because it is the highest exponent, and alphabetically a should come first. Next for my a's would be a squared. So I'm going to bring this a squared and combine it to this a squared. They're a squared b's, but that's okay. And I'll get 3a squared b. Then I'll combine my a to the 1st, so this plus this is going to get me 3a, and the b squared comes down. And then the last thing is the b, because there's no a with it, that would be tacked on to the end. Alphabetically, the term with only b is going to come last. So that's what I get when I simplify this. What the question is asking you is that always equal to this? Is this that I just circled in black the same as this? The answer is no. Okay. So I justified my work algebraically. I answered the question. I am done. So I want you guys to kind of get in the habit of doing this. And I've been doing it, but I didn't really mention it. Every single time you read a question, you're going to read through it, you're going to do it, and then I want you to go back to the question and read it again. Make sure you answered the question. Make sure you did it the way they asked you to. Make sure you didn't miss any information, and make sure that you either justified or explained your work if they ask you to do that. Use units if necessary, like if your answer is inches, put inches. All of that will come from reading the directions again. I know it's kind of annoying, but it does help significantly. For not missing any information or not making any oopsies. Okay. Number 28, probability question. It says the probability that a resident of a housing community opposes sending money for community improvement on plumbing issues is 0.8. That is a wild thing to do a probability about. Here we go. Next, the probability that a resident favors spending money on improving walkways given that the resident opposes spending money on plumbing issues is 0.85. Given. Determine the probability that a randomly selected resident opposes spending money on plumbing issues and favors spending money on walkways. So this was something that some of us were getting confused about during the probability unit. if you're trying to find an and, it doesn't necessarily mean you have to use one of the and probability things that we talked about, like the and formula. The words given and or are the most important words in a problem. If you have the word given, you're going to use the given formula because and is included in the given formula. And same thing, I know it's not relevant to this question, but if a problem says or, you're going to use the or formula because it also has and within its formula, and you can use the or to help you find the and. Okay, so if I'm trying to use this given formula, obviously I need to know what it is. This is the probability of A given B. It's going to be equal to the probability of A and B over the probability of B. Now, something else that I highly recommend that I think will be helpful is change the A and the B, especially for questions like this where it's not like, oh, brown hair, blue eyes. Like, these are really long variables. So I'm going to write them out using this given. So when I read the given sentence again, it says the probability that a resident favors spending money on improving walkways given. So this one's going to be in favor of the walkways, just to shorthand it. Okay, given that the resident opposes spending money on plumbing issues. So oppose plumbing. Okay, and again, to shorthand this, I'm just going to call this F for favor and O for oppose. So that when I write this side, it's a little bit easier. This will be favor and oppose over just the probability of oppose, because that second thing goes on the bottom. That means this is going to go on the bottom. All right, so now I know what I need to do. I just need to plug in the information that's given to me. So the given was given. When I read that sentence that I have underlined, again, it says that the given is 0.85. So that's going to go over here where the given is stated. The and is what I'm trying to find, and that's over the probability of opposing. So I'm going to read that first sentence again to make sure that's the information that's given, and it is. It says a resident of a housing community opposes spending money on plumbing is 0.8. So the 0.8 is going to go on the bottom, and now I need to solve this for x. So x is being divided by 0.8. To solve for x, I'm going to divide by 0.8. I'm sorry, multiply. I don't know what I just said. It's being divided. I'm going to multiply. So that ends up getting me x here, and then I have to multiply those two things together. It'll get me 0.68. So, like I said, go back in the directions to make sure you didn't miss anything. Sometimes it might say what percentage or something along those lines. This one just said determine the probability, which means you can leave your answer as 0.68. You can write it as a percentage. You can even write it as a fraction if you want to. It'd be 68 out of 100, but that simplifies to 17 over 25. So however you write your answer is fine because it wasn't specified, but always make sure you go back up to the directions to see what it wants you to write your answer as. If it's at a fraction, you would have had to write it as a fraction. All right, 29, Rowan is training to run in a race. He runs 15 miles in the first week, and each week following he runs 3% more than the week before. Using a geometric series formula, find the total number of miles Rowan runs over the first 10 weeks of training, rounded to the nearest thousandth. So, geometric series formula. You guys hopefully know by this point that every exam has this reference sheet at the back. Geometric series is on it. So you would flip, if you were doing this question on a real Regents exam, you would flip to the back, you would grab that formula, and then you would copy the formula down. Remember, partial credit is available for this. To get full credit, you have to show every step. So I'm going to write the formula from the reference sheet right here. Please make sure you copy it correctly. That would be a bummer. And now I need to figure out all the stuff. So the stuff that I have to plug into this is my first term, I need the R, and I need N. So let's pull that information out of the problem. So he runs 15 miles in the first week. That's my first term. It's going to be 15. So if I'm writing this as a sequence, it's 15. And then the pattern continues. Each week following, he runs 3% more than the week before. We'll talk about that in a second because that was a real trick with this question. This says, using a geometric series formula, find the total number of miles Rowan runs over the first 10 weeks. If he's running for 10 weeks, that means I'm going to have 10 total terms. So that means that N is going to be 10 because N represents the number of terms that you have. So N is 10, A1 is 15. Those ones weren't too hard to figure out, but the rate is complicated. So we know if we have a percentage in a problem, we have to convert it to a decimal, so it's 0.03. However, if I multiply 15 by 0.03, it gets smaller because multiplying by 3% takes 3% of it. And this one is going, he's running 3% more than the week before. So this should be going to a higher number by 3%. For something to increase by 3%, you want to use this idea. It is 1 plus the rate. So 1 plus 0.03 is going to be a rate of 1.03. It's almost like when you used to do like sales tax questions and stuff, you'd have to multiply by 1.08 to find out the amount of money with the sales tax included, because you're not just taking that percentage, you are adding it to your original amount. So my rate's going to be 1.03. Once you have that information, the rest of the problem's not too hard. I'm going to plug everything in where I see it needs to be plugged in. So this is 15 minus 15 times 1.03 to the 10 over 1 minus 1.03. Okay, now a reminder of how to plug this into your calculator. You plug in the top first, press enter, and then when you divide by more than one number, you either have to put it in parentheses, or what we did more often in class is we just simplified that to one number. That one number would be negative 0.03. All right, off I go. So on top, when I plug that into my calculator, I don't think I need to show you that one. Just give it a practice. This is the decimal that you should get. And that's still over negative 0.03. And then when I divide them, this is the answer that I should get. So if you need to pause the video, take a second to pause it, practice plugging it in your calculator. Me writing it right now just shows that I know how to plug it in. You need to know how to plug it in as well. And now once it rounded to the nearest thousandth, sorry guys, I'm still at my classroom. What was I gonna say? Nearest thousandth is 3 places after the decimal point. So 177 point, this is 958. I go 3 digits out, and then you look at that 4th digit. It does not have enough power to bump that up, so this is going to be my final answer. All right, on to the next number. Just a review of that real quick, by the way. A series means you add all of the numbers together at the end. So a series, like the formula, what this formula is doing is it's adding the first term, the second term, the third term, 4th, 5th, 6th, all the way to the 10th term. It's adding them all up. So think logically about your answer. If we're starting at 15 and like increasing by 3% each time, and I ended up with like a negative 171, big red flag that that's wrong. So just think logically about your example, and that's all I really wanted to say. Okay, this question, so much work is involved. So it says the average monthly high temperature in Buffalo in degrees Fahrenheit can be modeled by the function blah, ew, where T is the month number, where January equals 1, February is 2, and so on. State to the nearest tenth the average monthly rate of temperature change between August and November. So this right here, average monthly rate of temperature change is AROC. So I need my average rate of change formula, which is y2 minus y1 over x2 minus x1. Now it tells you the interval of points to use. It doesn't specifically give you the points anywhere in the problem, but it says between August and November. Now, I'm using B and T for this one instead of X and Y. T is the number, like the month number. So this one is going to be T equals 8, and November is going to be T equals 11. Now, even though it's not using X and Y, you should hopefully know that since T is within the equation, that's your X. So really, these points are 8, something, and 11, or November, something. I wish you guys could just do that on paper, like pick something up and just slide it over when it's in your way. It'd be so great. Anyway, so the next thing that I have to do is plug these in to find the missing y values. So this is going to be my x1, y1. This is going to be my x2, y2. To figure out what those are, I'm going to have to plug them into the calculator. So, as awful as this is, I'm going to teach you a little shortcut, but you have to plug this whole entire equation in and plug in your 8 and your 11. So the shortcut is the store button. It might not seem worth it, but just hear me out for now. I'm going to do 8 stow. Oopsie, I hit the wrong button. 8 stow. Stow is right down on the bottom of your calculator next to the 1-ish oops, I held it down to show you and it typed it 100 times. So 8 stow x, and then press enter. What you just told your calculator is now every time on this screen, not for graphs, every time on this screen, it's going to plug in an 8 for your x value. So at this point, what I can do is plug in this function exactly how I see it, putting an x in place of t, and then it's going to plug in the 8 for me. Again, might not seem worth it, but just hear me out for now. One other thing, before I start plugging this in, is I have to look at this. This is a trig function that I am plugging into, and I am not plugging in degrees. So in your calculator, you cannot be in degree mode. So press the mode button on the top left of your calculator, highlight over radian, and press enter if you are not already in radian mode. When you reset your calculator at the beginning of the exam, it'll already be placed into radian mode. I believe. Actually, give me 1 second to verify that. I don't want to lie to you. Let me just clear my calculator. Okay, yes, it automatically puts you in radian mode, so you will not have to worry about changing it unless you have to plug something in degrees. Otherwise, it'll just be in radian, but just double check anyway. So I am in radian mode. I am good to go. So I'm going to get out of this by hitting second quit. And now we got to type this in. So I already stored 8 for x. Now I need to type in this equation. So this is the horrible part. And I already messed up. 25.29. Double check along the way, you guys. It's so important that you type this in right. This is 0.4895 x minus, I have to say it out loud. Maybe not. 25.29 sine. Just double checking. It's 1.972. Close your parentheses where they do as well, and this will be 55.2877. Great. So since I typed it in with the x, my calculator is going to plug in the 8 for me, and this is what I get. So that's going to be my y1, so it's 28.86622497778. Can you round that early? No, 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 no. You never ever round a decimal until your last step. As horrible as that is, you can't. So next thing I have to do is plug in the 11. Here's where the shortcut comes in now. I'm going to do 11 stow x, and then depending on your calculator, hear me out. If you have the 83 calculator, press second enter, second enter. What that's going to do is copy and paste that big long equation for you, but now it's going to plug 11 in. If you have the 84 calculator, you scroll up by pressing the up arrow until you're highlighted over the equation, and then press enter. It just copy and pastes it for you, but now it's going to plug in the 11, which is perfect. But that's not the right number. What did I do wrong? What did I do wrong? Oh my gosh. I'm actually so happy that just happened. So look how easy it is to mess this up. Instead of 55.2877, I typed in 5.2877. And the whole thing would have been wrong. Ooh. Oh, that's frustrating. Okay, here we go. Doing it all over again. Oh my gosh. Okay. So I'm going to store 8 again. So 8 stow x. So I can start this over. I'm going to copy and paste this and just insert that. So it's 55.2877. I should have looked at my key. I was so confident. Okay, so it's 78.866. Even when I'm careful, you guys watched me like double check that. Even when you're careful, something can go wrong. Just be like extra careful, extra. I know people make mistakes, but oh, that's so frustrating. Okay, next I'm going to do 11 stow x, and now I'll do that copy and paste thing where I copy and paste that in, and here we go, 48.5979602476. And just a reminder, again, you cannot round those. Whole decimals. So now I know what my x1, y1 is. I know what my x2, y2 is. Now I need to plug it into my AROC formula. So the average rate of change equals my y2, yuck. Here we go, 5979602476 minus my y1, 78.866. If you're at any point in the exam wondering, like, do I really have to write that out? Just do it. It's the actual exam, like the final test of your knowledge. You don't want to lose points for not showing something. Okay, so I'm going to copy and paste these numbers minus that for the top. I get, oh my gosh, I just did it wrong again. It is this one minus this one. There we go. Negative 30.268264730 over 3. So I divide that, and I get negative 10.089421. Do I really have to write out the whole decimal? Yes. Yes, just do it. It is your exam. No lazy, no lazy. All right, then it says to the nearest tenth, which is negative 10 point, this is the 10th, but the 8 will bump that up, so it's negative 10.1. Now remember, these are all 2-point questions, and we're not even done with this. So if you have to think about this in terms of like giving out points, this first part was +1, this one had to be +1. There's no other way to give out 2 points for this. So everything we just did was only worth 1 point. I made a mistake, I would have lost the full point. Even if the rest of my math was right with the wrong number here, it would have all been totally wrong. Okay, be as careful as possible. Also, rounding. If I rounded this wrong, I would have lost a point, and everything else I did wrong. Be careful. Okay, now the part B, explain its meaning in the given context. Whenever a problem says in the given context, it means you have to talk about the context, believe it or not. It says average monthly high temperatures in Buffalo. That's what we're talking about here, so I need to be mentioning that in my problem. So I'm going to write the average monthly high temperature. Should I write temp? No, temperature. The average monthly high temperature decreased. I'm going to write decreased because my average rate of change was negative, so it decreased by 10.1 degrees Fahrenheit. Each month, that's what average rate of change means. You're finding that average rate of change each unit. This one was each month. And it's only happening between August and November. The average rate of change each month would be different if, let's say, I used January to February. Okay, the average temperature would be different. 78 was the average temperature in August. 48 was the average temperature in November. If I use different months, it would be different, so I need to state that as well. Okay, a lot of work for a 2-pointer, but honestly not too bad as long as you don't do what I did and plug that number in wrong. All right, number 31. This is going to be a lengthy part of the video, but I'm actually going to show you both ways that you can solve this one. First one is going to be the Pythagorean identity. Next one is going to be using SOHCAHTOA. If you already know your preference, skip to the video. Like if you prefer SOHCAHTOA, just skip the first part. If you don't know your preference, watch them both and then decide. So before I even start these, I need to talk about why those are my 2 methods. It says point M, which is t comma 4 over 7, is located in the second quadrant on the unit circle. Unit circle is a huge keyword saying you got to do some trig. The reason I'm going to use the Pythagorean identity is because I have to find the value of t, and if this is on the unit circle, that means t is cosine and 4 over 7 is sine. If I know sine and I'm trying to find cosine, I can use the Pythagorean identity, which is cosine squared of theta plus sine squared of theta equals 1. So to repeat, if I know sine, I can easily find cosine by using the Pythagorean identity. The reason you could use SOHCAHTOA is because, once again, SOHCAHTOA is trig, but sine is given as a fraction, which means that sine being 4 over 7 is your opposite over your hypotenuse, and then you can use that to help you find the cosine. So I'm going to focus on Pythagorean identity first, and then we'll get over there. So since I know that sine is 4 over 7, that's what I'm going to plug it in for. This is going to stay cosine squared of theta, and sine is 4 over 7. Now, sine is 4 over 7, but this is sine squared, so I'm going to bring down the squared, and that equals 1. So the first thing I'm going to do is actually square that. It's cosine squared of theta plus, because this wants an exact value for the answer, that means no decimals. If I do 4 over 7 squared in the calculator, I'll just show you real quick. 4 over 7 squared, I get a decimal. I don't want that. So I want to just square this, or you can math enter it. If you math enter it, you get 16 over 49, but you could just square this in your head. On top, 4 squared is 16, and on the bottom, 7 squared is 49. Okay, now to keep solving for cosine, I'm going to now subtract the 16 over 49 over. Again, don't want a decimal. So this is cosine squared of theta equals, when I subtract those, 1 minus 16 over 49 gets me a decimal. Don't want that. Math enter will get me 33 over 49. And then here's where the kind of weird part comes in. I'm trying to solve for cosine, and right now I have cosine squared, so I'm going to square root it. But if you square root that fraction, you get a decimal that doesn't convert to a fraction. Then you start to panic. Don't panic. If you have the square root of a fraction, it just means the square root of the top over the square root of the bottom. So when I simplify that, I end up getting that the cosine of theta stays the square root of 33 because I can't square root that over the square root of 49, which is 7. So that is almost my answer. Remember, this is a 2-pointer, so all that work could have gotten you to this, and it's still not even done. You need to focus on what quadrant you are in. If I am in the second quadrant, A, S, T, C, second quadrant is right here. Sine is positive in the second quadrant, and I was finding cosine. That means my answer is negative. This is the final answer. If you like that method, great. If not, here we go. I almost said sen, castan. I don't know. So, ka, toa. Sorry, a little sleepy. Again, the reason I knew I could use SOHCAHTOA for this is because sine was given as a fraction, so I know that it's opposite over hypotenuse. And it's in the second quadrant, so I'm going to draw a picture like a good student. And to draw a triangle in the second quadrant, or any quadrant, you want to follow the bow tie method. If the second quadrant means I'm coming out from the center and then going perpendicular to the x-axis. So I'm going to put my theta right there in the middle, and I'm going to label this now. This is the opposite because it's on the opposite side of my theta. The adjacent is the side next to, and the hypotenuse is across from the right angle. So this is my hypotenuse. Okay. I know that sine is opposite over hypotenuse. So my opposite is 4, my hypotenuse is 7, and I have to find the cosine. Cosine of theta is going to be equal to adjacent over hypotenuse because of this, ka. The problem with this is I don't know what the adjacent is, so I have to do some math to find a missing side of a right triangle. That's going to be a squared plus b squared equals c squared. So if I'm trying to find the adjacent, it's going to be either a or b. I'm just going to leave it as a for adjacent, because why not? The opposite's going to be b. The big idea with Pythagorean theorem is that the hypotenuse is always across from the right angle, and it has to be your c. So my 7 squared is going to go here. So this is a squared plus 16 equals 49. Those numbers look familiar. I'm hoping we can solve this one pretty good. I get a squared equals 33. And then when I square root that, I get that a is equal to the square root of 33. So that means my adjacent side is the square root of 33. Now that I know my adjacent, I can plug that in. I get the cosine of theta equals, my adjacent is the square root of 33 over my hypotenuse, which is 7. And then once again, in quadrant 2, sine is positive. And I was finding cosine, so that means my answer is negative. Right, 2 different methods. Obviously, you do not need to do both. This is a one or the other situation. But pick your favorite, see which one works better for you. But I think that one was kind of a lot for 2 points, too. Okay, 32. We have done so many log graphs on Regents exams. We need to get this down. It is a very common question. On the grid below, graph the function blah. So once again, depending on your calculator, if you have the 84, sorry, it is math, alpha, math. If you have the 83, it is the log change of base formula. It is the log of what's in the parentheses, or what you're taking the log of, divided by the log of the base, which is 2. And then there's a little bit more with this one. You have a plus 1 on the end as well. So I go to my calculator, I go to my y equals. I'm going to do math, alpha, math. This is log base 2 of x minus 3. Get out of the parentheses and then plus 1. I am also going to type it in to show you for the 83 people. You press the log button next to the 7, of x minus 3, close your parentheses, divided by the log button again of 2, close your parentheses, plus 1. So you can hit graph to see what it's supposed to look like. Obviously, I have them both graphed, so I don't need that. I'm just going to clear that one out now. But this is what my graph looks like. Just a reminder, it technically doesn't actually look like this. It goes down and down and down. We'll talk a little bit about that in a second. But ultimately, I need my table. So I'm going to go up to my table. I'm glad that popped up. The error is super important, so I'm going to, do I have more? Oh my gosh, come on. I'll show my work over here. So I'm going to write my table right here. 3 has an error. 4 is at 1. 5 is at 2. I'm not going to do 6. I'm going to do 7, 3. And then it looks like 11 will fit, so I'll do 11, 4. And then the next nice point is 19, 5. That one probably won't fit, but I'll just put it on there for good measure and get that out of my way. Okay, so when I plot these points, you can't plot an error, so we'll kind of ignore that 4 now and plot the rest of the points. I have 4, 1, 5, 2, 6, 7, 3, 8, 9, 10, 11, 1, 2, 4. And I can't fit that last point on there. So you do not connect it like this. It continues on. You also don't want to just like randomly do this because that will get you a wrong answer. What we need to do next is draw in our asymptote. The asymptote is where you have an error on your table. I have an error at 3, so that means my graph does not exist at 3, and that's the definition of an asymptote. It is the line that your graph approaches but never touches. So my asymptote is at x equals 3. And now when I connect all of my points, did I graph? Yeah, I did. When I connect these, it's going to go like this forever in this direction, but when it comes this way, I can't hit that asymptote. It's just going to get close to it, but it's never going to actually hit it. And that's my graph. I'm going to label it for good measure. Log base 2 of x minus 3 plus 1, and there we are. Perfect. All right. Oh, and that was the last one. So that is the end of this video. If you have questions, please feel free to reach out to me on Schoology or Remind, and good luck.